Stat 4.3. Normal model Z-table.
Hey, you're copying this, please.
So, something to note in regards to this, we have talked about the 68, 95, 99.7 rule. This rule approximates the area under the normal model for z-scores of -3, -2, -1, 0, 1, 2, 3. Area between. So what that model does, it says how much of the area, or as we said, percentage, lands between -1 and 1, -2 and 2, -3 and 3. And from those calculations, we were also able to break it down even more between, we could do -3 to -2, -3 to 2. This was the version 2 that we had. But it only works for between or above or below those values. Now, something to note. I do want you to note this. 68% is the same thing as 0.68 probability. So when we're doing this work for here, it is going to be okay to leave your answer in decimal form. Decimal form answers acceptable. You're going to see that in the instructions, it's going to ask you, what is the probability? What is the percentage? What fraction? Most likely, I know we haven't done our unit on probability yet, but it's the same thing. So when I say something like 68%, that's the same thing as saying the area is 0.68, meaning that the entire area is 1. So the whole thing is 100%. Remember, the whole 100% as a decimal is just the number 1. So the entire area under the normal model is 1. All right? And of course, we were using the percentages. You can convert the answers to percentages if you wish to, but feel comfortable just leaving the answer as like 0.68 and then that's it. Or 0.95 and that's it. 0.32. This helps us because all our answers that we get today should be between 0 and 1. So the minimum area would be 0. It can't happen. It's impossible. To the maximum area being 1, it's certain. It has to happen. It's guaranteed to happen. So, what about other z-scores? Man, you do not like me. For that, the answer is what we call a z-table. So the z-table is what we're... The z-table lists, or sorry, I'll say states. Man, wait, stop doing that. States the probabilities area below cut off z-scores for the normal model. Now, please note, it's below, all right? All of the answers that are on this z-table that you see in front of you are for answers of the area below. What percent of students score below a 400 on the SAT? What percent of students have a height that is under 60 inches? So everything is for under, not the betweens. Cut off, yes. But it's also, please note, it's using z-scores. So everything needs to be converted to a z-score. So your first step that you're going to have to do in all of the problems is to find the z-score. So how do we use it? How to use. Step 1. What's step 1? What do you think step 1 is? That's a previous review one. What is the first thing we're going to have to do? I just literally had said it right before I go. We're going to every single time you're going to have to find the z-score. For that, you're using that formula, z equals x minus the mean all over the standard deviation. You will be given the mean and standard deviation like Romano's. In the problem that you just saw about Romano's Pizza, we were given the mean, we were given the standard deviation. And then will come the next question. What percent fall below a certain number? Okay? Step 2. Make a sketch of the shaded region. Okay, so we're going to make a sketch. That sketch might look, it doesn't have to be precise, just something like this and here. And then we'll state what the mean is. So like we might write like the mean is 28. And then we have the z-score over here. And we might shade it like this. Okay? This is what I'm looking for. Maybe it's like 30 minutes. And it gives me a z-score of 0.5. Something like that. The shaded part will help us make sure that we know what we're doing. All right? Step 3. I'm just doing like an example. Step 3. Use the z-score to find area below. If area is above, use 1 minus the area below. Now, this last part can get a little bit tricky, but I'm going to pause right here. So the answer is either whatever the number is, the area, or what is half of the area? What is half? What is half if it was exactly half? What percentage is below exactly half? The mean. What percentage, or what would be the area? What percentage falls below the mean? A z-score of 0. What percent falls right? What is half of the whole thing? 50%. Did everybody agree? what would be the decimal number? 0.5. Okay. If this is my picture, and this is what I shaded, my answer is going to be less than 0.5 or more than 0.5. It's going to be more than 0.5 because I know 0.5 is right here, right? Sorry. I know 0.5 is right here in the middle, so I know that this is more than 50%, more than 0.5. So when I look at my answer, if I look at the table and I see 0.3, I should go, wait a minute, the answer can't be 0.3. Oh, 1 minus 0.3. It has to be the other side. So 1 minus 0.3 gives me? 1 minus 0.3 would give me?
1 minus
0.7. And that would be the correct answer. If I looked at the table and I see 0.3, and I go, wait a minute, that's too little. I know my answer has to be more than 0.5. 1 minus will always get you to the answer because that's everything. Remember, so if what I'm trying to tell you is if this is 0.7, then the unshaded would be 0.3. They have to add up. Both sides have to add up to 1. It has to add up to 100%. Okay? All right, so now let's take a look at this table and how to read it. And then we'll do an example, and then we'll be done. So, there's two sides to this table. One side is for positive z-scores. When you get a z-score that is positive, that's one side. And the other side is for negative z-scores. So this first side that you see in the front is for negative z-scores. So this is for z-scores that are going to be falling below the mean, which means all the z-scores will be negative. Which means all of the answers are less than or equal to, for the areas, all the areas are less than or equal to? What? All the areas are less than or equal to 0.5. Look at all these numbers inside the middle. You see all these numbers inside the middle? It is. Those numbers represent the areas. How do I read it though? So the way this table is made is that these are the z-scores on the outside. So for example, if I had a z-score equal to negative 1.35, okay, what are the first two numbers? No, what are the first two numbers, not the last two? What are the first two numbers? What are the first two numbers?
1.3.
Close. Negative 1.3. So my first numbers are negative 1.3. So on my graph, I'm going to go down, and I'm going to find negative 1.3. And then what's the next decimal number?
5.
So then I go to 5, and I just find where they intersect, and there would be my answer right there. So for negative 1.35, for this example, I would go to negative 1.3 and then 0.05, and that's the area under negative 1.35 for a z-score.
So it's
0.0885. You just write those answers. Example, the area equals 0.0885. Here, 1.35, which would give me right here. Huh? There's going to be time. We have time. Those going to go to early college, they might not have that, but there will be time. Now, here's something to note. The normal model is perfectly what? The normal model is perfectly what? Symmetrical. So, if you know what area is below, the z-scores are also perfectly symmetrical. So notice that this one gave me 0.9115. If I add that to what I just found previously, 0.0885, the two numbers added together give me 1. You can use that if you really feel good at understanding symmetry. When you know one answer, you know the other. So this is my advice to you. You should know all your answers have to be positive. Your areas always have to be between 0 and 1. If you can figure out if your answer is greater than 0.5 or less than 0.5, when you look at the number, it's either that's the answer or 1 minus that number. It will work every time if you can utilize that common sense for that piece. So let's do an example. So how is this problem actually going to be done? So let's do an example. We'll do a couple of problems and then we'll be done. Same problem we've been working with. IQ scores are normally distributed with a mean of 100 and a standard deviation of, so I wasn't supposed to write that word, and a standard deviation of 16. A. What percent, same thing as probability, what percent of scores, of IQ scores, are less than 116? Now, this is a question that we did answer on our previous homework, on the homework that is due tomorrow. We did answer this type of question. We can add up all of the sections that are, this is exactly 1 standard deviation above, and we want to find out how much is below that one. So the answer, if you can recall, is 84% when you use the normal model. That's what we would have gotten if we used the 68, the empirical rule. I'm going to show you how to do this problem a lot easier, though. All right. So what is the z-score? How do I find the z-score? We know my mean, we know the standard deviation, and we know the score that we're looking for. So z equals, okay, z equals, you're giving me the formula, but not what to do. Z equals x minus the mean over the standard deviation. That's what we're using. But now we just got to plug in those numbers, people. This is what I said. You're going to have to be able to find a z-score. What is x? What is the value that we're looking for? 116. Minus the mean, which is 100. Here we go. So the mean is 100 in this problem. The standard deviation is 16. So 116 minus 100 over 16, which gives me 1. It's a nice, beautiful number. 116 minus 16 is 100. I am looking for the area below. So in my graph, here's the center. Here's where 100 is. I am looking for the area below this z-score of 1. Like this. Okay? So is my answer going to be less than or more than 0.5? Is my answer less than? My final answer, will my final answer be less than or greater than 0.5? We're looking for the area, people. I don't know how, there's a 50-50 chance on this guessing rise, and every single person keeps saying less. The answer is more than 50%. The answer is more than 0.5 because this shaded is higher. It's going to cover more than 50% of the graph. So I know my answer is greater than 0.5. I told you what the answer is, 84%. 0.84, right? So now we're going to go to the z-table. So which side am I looking at? The front side or the back side of my z-table? The back side. And 1 is also the same thing as what number to 2 decimal places? The number 1 is the same thing as what number written to 2 decimal places? 1.0. 1.00. The number 1 is the same thing as 1.00. Please try to find it on your own. Can you find the answer? Can you find that answer before I show it to you on the screen?
Use the handout we gave you to help yourself, please.
We're looking for z-squared of 1, also known as 1.00. Can you find what the answer is before I show you? Find out where they intersect, where 1.00 intersects. 1.0 and 0. What did you say? No. No, I don't know what you guys are doing. One. 0. Wait, what? Yes? What? Point. That's going to be it. So 1.00, which gives me this number right here. 0.8413, which is about 84%. That's about 0.84. Wouldn't you agree? So when we were doing that empirical rule of the stuff we did on our last 4.2, we got 84%, which is like 0.84. The exact or more precise answer is 0.8413. And that's it. The answer for the area is 0.8413. And you could just leave the answer as 0.8413. This is the same as 84.13%. It is the same thing, but again, you don't need to turn it into a percentage. You don't need to move the decimal over. You can just give us the answer as 0.8413. B. What percent of IQ scores are less than what? Less than what? Give me an IQ score. No, that's too easy. We already did that one. That's a perfect integer. Something that doesn't land on the empirical rule. 136. Okay. What am I going to find first? What do I find first? Yes. Z equals 136 minus 100 all over 16. The standard deviation is 16. In this problem, it's always 16. In this problem, the mean is always 100.
It will tell you, or you'll have to find it. But
It'll always tell you.
But you know how to find it.
So I go to my calculator. 136 minus 100 is 36. Divided by 16. And I get 2.25. 2.25. Well, that's the z-score. That's step 1. What do I do now, Drew? So I'm looking for z equals 2.25 on the positive z side. And now, please, as we're writing it down, look at the table. Can you find the area below 2.25 for the z-score? The z-score is 2.25. This is 2.25 standard deviations above the mean. What is the z-score? I guess I don't want a little bit more time to be able to go over that. What do we get? No. Oh, yeah. Yes. So, again, 2.2, and I go over to 2.25. There's the 0.5. 2.25 gives me right here, and there's my answer right there. Boom, that's it. 0.9878. So my answer from looking at the table, my area is 0.98 what? 78? And that's the answer. Done. That's the same thing as like 98.78%. But we're just going to leave the answer as a decimal in stats. It's much easier in statistics just to leave our answer in decimal form without converting it over to a percentage. Here's a quick, easy one. What percent is above 136? This is a quick follow-up. I don't even have to look at the table because I already got all my answer. I can skip the first step. Step 1 is done. Step 2 is pretty much done as well. Yeah, so how would I find this answer then? If I know the area below, no, it's not even there. Oh, you could do that method as well. Yeah, so trees that, wait a minute, it's symmetrical. I can look at the negative one. So if I look at negative 2.25, it'll be there. Yes, that is true. If you want to do that, you can use that knowledge. I'm going to just do it a little bit easier though. If below is this, how do I find how much is above? I subtract. So the area equals, what do I subtract it from? How much is everything? 100%, which is what? What's 100% as a decimal? What's the whole thing? What is everything? 1. Don't overthink it. It's 1. Minus 0.9878. Just 1 minus. If you want to find the above, 1 minus what the below is. Which gives me 0.0122, less than 1%. Less than, or just a little bit over 1%. About 1% of individuals. You think there's not enough time? Sure. We can do that tomorrow. Do between? All right. All right.
We don't have homework. So just
Yeah.
bear with us for the last 4 minutes.
So, this is area between. What percent of IQ scores are between 100 and 136? Okay, I didn't put this up here. This is the last one that we need to do from here. Now, we've already found the 2 z-scores. Or, sorry, this would still be 116. Sorry, it was 116. I want to stick with it. 116, which was part A, and B, which was 136. Okay? So, the first z-score, I got what? Close, you're close. The first z-score for this, I got a z-score of what? I already did it. What was the z-score for 116? What was the z-score for 116? It was the first problem that we did. What's the z-score? 1. It's right there. Part A. Okay, the z-score is 1. For 136, what's the z-score? 2.5. All right. What was the area below for this one? The area here below was 0. What was the answer for A? 8413. It's the answer for A. It's right there. 8.8413. And what was the answer for this area? For 2.25, the one that we just found, the area below. 0.9878. To find the area between, yes, subtract area below, areas below. So my answer My answer for area between is 0.9878 minus 0.8413. We just subtract the two answers. Well, think about this. I told you the answer is always for area has to be between. It has to be positive. It can't have there's no such thing as a negative number. So if you were to accidentally subtract the other way, you should trigger your mind and say, oh, I can't get a negative. So I just write the positive. It's always the bigger area minus the littler area. Which gives me what? 0.9878. 0.9878 minus 0.8413, which is 0.1465. And that's how you use the z-table. You need to practice. So some things that we've learned right here, Miss Page is going to lead you tomorrow in it. Tomorrow, we need to revisit how to find z-scores. So Ms. Page put together a piece of notes that she's going to lead in tomorrow.
Don't lose it.
Don't lose it that she gave you.
Or you can do it for homework. What would you rather?
Do it together.
You want to do this together?
Well, they should try to do it for homework. They can try to do it for homework. And then